I don't know. It was odd.
Maybe like had too many subscribers coming in and overloaded the system.
Maybe so. They're like, wow, this site is too popular. It can't be educational.
Most likely.
But yet, it's just my YouTube. Alright. Okay, so that was just review we did in our warm-ups. And we'll take a look at your classwork from yesterday and your homework from last night. So yesterday's classwork was like 12 different scenarios that we could set up as a system and solve. Now you didn't have to set it up exactly the way I did. And honestly, if I hadn't said let x equal this and y equal this, I would probably not have used x and y as my variables in very many of these. But set it up for you and let's go with it. Alright, so on number 1, you could let Ariel be x or y. So, did you guys realize that the question or the statement where it's telling you what to do tells you how to define your variables? Find their ages. So what are our variables? The ages of the people.
Right.
How many of each were sold? So how many tickets of each different kind were sold? Find the dimensions. Well, your variables have to be the length and the width. So the question basically tells you what your variables have to be. So in this one, it's their ages. So if I let x represent Ariel's age and y represent Ben's age, then we would have this scenario. Because Ariel's age, x, equals twice that of her brother Ben, 2y. Now if I reversed it, I'd have y equals 2x, which you might like better just because it's y equals, and sometimes we like that better. So if you had reversed it, that would be the case. But this second equation wouldn't change at all. X plus y equals 20 because the sum of theirs is 24. X plus y equals 24. So I would probably use substitution. Since x equals 2y, plug it in. Get y is 8. So Ben is 8 years old and Ariel is 16. Any questions about number 1? Okay. Number 2. And you could have labeled these a couple of different ways. We can let x represent the number of bleacher seats that were sold, and y represents the number of other types of seats that were sold. So all the people that sat in the bleacher seats and all the people that sat in the other seats would total all the people, wouldn't it? So that's where this equation came from. It tells me in this sentence the receipts from the baseball games were $12,920 paid by 4,120 spectators. So I know there's that many people. So the people that sat in the bleacher seats plus the people that sat in the other seats total all the people. And then my second one has to do with money. $2 for each bleacher plus $4 for every other seat equals the 12,920. Now if we took this top equation and multiplied through by -2, then we can solve it using elimination. And any way you solved it, you should have gotten these two answers. Do you notice how I didn't tell you how to solve it? You get to pick?
Yes, ma'am.
Yeah, and you get to pick. Do you want to use substitution? Do you want to use elimination? I probably wouldn't use graphing. Graphing is the more difficult one. Okay, this one talks about perimeter. Well, we know perimeter is 2 times the length plus 2 times the width. So if I let x represent length and y represent width, then 2x plus 2y equals the 132, which is what they tell us the perimeter is. And then the length is 2 more than 3 times the width, so x is equal to, the length is 2 more than 2 plus 3 times the width, 3y. I would use substitution since this one's already solved for x. Substitute it in and solve. You get x is 50, y is 16. So how would I answer this question? I would say that the length is 50 centimeters and the width is 16 centimeters. Okay, number 4, the larger of two numbers is 7 more than twice the smaller. If 5 times the larger number is subtracted from 12, the result is 17. Find the numbers. So I have a large number and a small number. The large number is, so x equals 7 more than twice the smaller, so 7 plus 2y. And then if I rewrite that second sentence into an equation, do you see it only has one variable? So this one, we don't even, right here we can just solve for x and substitute that in to find y. And you should have got -1 and -4. Any questions? Okay. Alright, I'm not going to talk you through every one of them if you don't need me, but take a look at 5 and 6 and see if you have any questions. Of course, this will be posted on my website. Have you guys frequented the website?
I have.
I have.
I have actually been there.
Okay. All right. Every day, the notes that I put on, every day the notes I do are posted, and they're posted by date. So if you're ever absent, you can go to my website and click on the date for that you were absent, and you can see all the notes I did in class. Yes, sir.
I tried to get on once, but it said that your site wasn't an actual site.
That happened to be the first one.
Okay.
I think I might have accidentally put it in.
Let's
wrong.
take a time out then. Let's go check that out.
That made
I
me
did that
smile.
once and then I did it again and it came out.
Look at my chicken.
Keep on trying.
It's not an actual.
Oh man.
Okay. There's a couple ways you can do it. You can go to the Stars Mill website. You
Right.
can Google Willoughby World, and you see what pops up. All right. So here we go, Willoughby World map. That's me. You click on that, and apparently you wait a long time. There we go. Now it's doing something. And there's my website. So
Okay.
if you went to this class, you're in coordinate algebra. You click on that, and you choose what you want. What unit are we in? We're in Unit 2,
Okay.
and this is what we're going to learn this unit, and this is what we've done so far.
And those are the notes.
And there's the calendar, and there's the date.
Awesome.
Will we work?
Oh wait, hold on. Where is the calendar?
Over there.
It's the one that
Oh,
right there.
I see it.
I need
Okay.
to print that out actually.
And
I was
if you,
trying to find
yeah,
it.
you can download that or open it up and take a picture on your phone or whatever. That tells you about your assignments and your tests. And then my main page has the link to my YouTube. So if you are absent, you can go to the YouTube, click on YouTube. So far I've had 822 views, but I only have 14 subscribers.
I thought you were at 11. That's an increase.
My latest video was from this morning. And then the last one I did in this class was on the 3rd. Well, last week they locked me out of my YouTube, so I couldn't upload anything. Alright. That was a nice break. Check 5 and 6 now.
I got them right. How about that? What? Like everything I do, even what is not, is life.
Alright, are we ready to move? Okay, here's 7, 8, 9. Okay, after I looked at number 7 again, 12. Now, number 12 was not a hard system, but when we went to solve it, we did have some fractions in there, but they weren't difficult fractions. Okay. Workbook. Now, this was complete and total review from last year. Did you remember it, or did you have cobwebs in your brain? You remembered it? Excellent. Okay, so testing the point to see if it made a true statement. If it did, then yes, it is a solution. If it made a false statement, then no, it is not. Any questions about 1, 2, or 3? Okay, 4, 5, and 6. We were graphing them. If it has the equal to, it's a solid line. Now, last period someone told me that their teacher last year told them if it's greater than, you shade above, and less than, you shade below. Okay, that is a nice shortcut if the equation is in slope-intercept form. But when it's not, like this one, when it's not in slope-intercept form, it's best to test a point.
I always do 0, 0.
And I do too.
Well, less is
I
smaller
do
than
too.
0.
So 0 plus 0, is that greater than or equal to negative 2? Yes, it is. 0 is greater than a negative number. So we would shade towards that point. And that's what I do every time. 0 is less than or equal to 0 plus 4. Well, yeah, 0 is less than 4, so let's shade towards that point. Here's 0, 0. If I plug it in, I get negative 1 is less than 0. Sure, shade towards that point. Any questions on 4, 5, and 6? Okay. All right. Number 7. We're going to concentrate on this again today. And then what we're going to do is help that lead us into linear programming problems, which we'll do for the next 2 days. All right, this one's quite simple. It says Clark is having a party at his house. His father has allowed him to spend at most $20 on snack food. He'd like to buy chips at a cost of $4 a bag and pretzels at a cost of $2 a bag. Write an inequality to describe the situation. So, did you define your variables?
Yes.
X is chips, Y is pretzels for me. So, 4x plus 2y is less than or equal to 20. Now, there are 2 other inequalities that are represented by this situation that you may not have thought of. And one of them is that the number of bags of chips has to be greater than or equal to 0. Does that make sense? That we can buy, basically this is saying you can't buy a negative number of bags. That's true. Okay, so that works for chips and for pretzels, which is why on the graph they only gave us the first quadrant. Because that's all we're dealing with. Where x is greater than 0 is over here, and where y is greater than 0 is up here. So we're just dealing with the first quadrant because in this situation you can't have a negative number of bags. So these are our 1, 2, 3 inequalities that we get from this situation. Now, it asks us to graph all solutions. So if we graph this and shaded this region, our solutions lie in that region. But because this question is specifically about number of bags of chips or pretzels, it's really only my whole number answers in here, isn't it? Those are the only ones that will truly work, because I can't go buy 1.5 bags of chips and 3.25 bags of pretzels.
You could, but they get mad at you.
You can't buy it that way. You could go in the store and open a bag and pour some out, but then that would,
Chips are
They'd be
already
mad at
like
you.
that.
That's what I'm saying.
yeah, they might prosecute.
You might have to bribe one of the store people.
Those are bad ideas. So we're only going to go with good ideas here. So any of these blue dots would actually work for this situation. We could go with any of these choices, and the ones that lie on the line, can't we? Because we can do at most $20, which means we could spend all 20. So if you were my child, you would come home with 0 change. I don't know. Do y'all do that to your parents too?
Should he have no tax? Sometimes I
A lot of areas there is no tax on food, or there's reduced tax on food. So sometimes there's none, sometimes it's reduced. So we're assuming we're living in the area where there's no food tax. All right, and so you could have picked any of those blue dots for your solution. Now tomorrow we're going to talk about how to find the optimal solution, how we can get the most for our money. All right, any questions on 8, 9, and 10? Can you write an equation given a graph? Because I chose to write all of these equations in slope-intercept form, I can go with that kind of shortcut idea, that if it's shaded above, it is greater than. If it's shaded below, it is less than. Because that only works in slope-intercept form, and I chose to write my equations in slope-intercept form. That's the easiest way for me to write an equation. Any questions about 8, 9, or 10? All right. Flip on over to page 133 in your book then, and we're going to change this a little bit. And then we're going to set up the problem. You're purchasing jeans and t-shirts. Jeans cost $35 and a t-shirt costs $15. You plan to spend $115. So if you spend $115, can you spend, well, I guess you could. Let's assume you do not have a credit card and you have $115 cash in your wallet. That's all you could spend. Can you spend less than that?
Yes.
Yeah, so we can do at most $115 then. All right, and I'd also like to change this. You're purchasing a total of at most 5 items. I don't know why that would be a restraint, but that is one of our restraints. Maybe you're one of those people that likes to have all your clothing on a certain type of hanger, and so you can, and maybe you put your clothes in color order. Are there any of those people in here?
I put my clothes in color order.
Do you really? Always one.
Just so I know, like, hey, I need a red shirt.
I do mine according to niceness. Like regular, and then collared, and then collared long sleeve, and then button downs.
Do you have a suit? Not even?
Well, I might, but it's not in my closet if I do.
Oh, okay. Your
I've
mom's.
worn one before. I'm gonna rent it.
Okay. All right. So they're just going clothes shopping. So we're gonna let. What variables would you like to use? It doesn't matter.
X and Y.
All right, my favorites.
I like M. Can we do M?
Well, if I were to not use X and Y, I'd probably use J and T.
Wow.
Okay, because my question always tells me what my variables are. How many pairs of jeans and how many t-shirts can you buy? So X is going to represent the number of pairs of jeans. And we'll let Y represent the number of t-shirts. I really like how the question always gives us a hint about our variables. Okay, now what we're going to do is list our constraints. What types of inequalities could we write about the situation that are limiting us? Well, there's the obvious ones that we're actually even going to write down. Can I purchase a negative number of jeans?
No.
No. So X would have to be greater than or equal to 0. Can I purchase a negative number of t-shirts? No. So Y has to be greater than or equal to 0. So this graph will be contained solely in what quadrant? The first quadrant. Yeah. Everything's in the first quadrant. Okay. Now I have 2 other things going on. I have how much I can buy and how much it costs. What would be an equality to represent how much it costs? I'm ready.
Y plus X has got to be less than or equal to $115.
Okay, so our number of jeans and our number of t-shirts together has to be less than or equal to $115. Now, this is cost. So how much does each pair of jeans cost? $35 times each pair of jeans plus how much does each t-shirt? 15 times each t-shirt has to be less than or equal to 115. Okay, so now we have a constraint on money. Cost, how much I have to spend. Okay, now this one has this other odd one that we can buy at most 5 items. So how would I write that? Okay, x plus y is less than or equal to 5. All right, and then I'm going to sketch a quick graph of this. What would this look like?
However you want it.
Oh, I just went the wrong way with that. Where's undo? There we go. Alright, so the first one, x is greater than or equal to 0 has us over here. Y is greater than or equal to 0 has us in the first quadrant. This one, this is a strange looking equation. But if I plugged in 0 for x, what do I get out for y?
Y is equal to 5. Wait, Joe, I'm sorry.
7. Good. And if I plug in 0 for y, what do I get out for x? What's 115 divided by 35?
Oh.
3.
3.
Oh, right.
Okay. All right. So there's those two. And am I thinking shaded above or below?
Below.
Below. So right in the little triangle, aren't I? All right. Now x plus y is less than or equal to 5. What are those intercepts? 5 and 5.
Yeah.
So it would look like that. If I plug in 0, 0, is 0 less than or equal to 5? So I did below, right? And so my solution region is right in here. Let me switch to my handy dandy highlighter. Highlighter? You can highlight that region. So that's my solution region. Okay? Anything in there would work. All right. Now, let's flip to page 139 in your book. This is a system of inequalities, and we're going to graph it. The first one has a y-intercept at 1, 2, 3, 4. I'm graphing it in blue. See? The slope is 1, so I go up 1 over 1. And then I would draw in a solid or dotted line, guys. Which one? Solid. That is not blue. I'll fix that in just a moment. Okay, think about this one. If I test the point 0, 0, am I shaded above or below that line? 0 is less than or equal to 4. Is that true? So I'm below. Shading below that line. Okay, now I'm going to do the next one in green. Oh, the y-intercept is 0, 0. So can I test 0, 0 in a minute? Nope, I'll have to pick a different point. Okay, my slope is -2. So I go down 2 over 1, down 2 over 1. Now draw in the line. Solid or dashed?
Yeah, that's solid.
It's solid. Okay, let's test 1, 1. Is 1 greater than or equal to -2?
Yes.
Yes, so I'm shaded on this side. Now, the overlapping region is the solution to this system. It's where this shades with that. And so I'm going to fill that with this beautiful pink color.
Whoa, that's big.
Thank you. That is the overlapping shaded region. So anything in that area is a solution to the system.
Go figure.
Look at
Oh.
Look at
Any questions?
I'm good.
Okay. You have a little bit more practice on inequalities tonight. Your homework is in your workbook. It starts on page 132 with 2 through 6. And then we're going to skip over to page 139, and you're going to 4 through 7. And then tomorrow we get to start the fun stuff.
What's the fun stuff?
Linear programming.
Oh God.
Oh yes.
That sounds fun.
Wait, what does it mean by A and B under that? I'm not following. Oh, okay, never mind.
Miss
I wasn't-
Willoughby, hey, are we gonna get to see our tests?